Do you love math? If you do, make sure to check if you follow the fifth commandment. Thou shalt honor the correct order of operations. If you love math, go check out Mr. Aim on YouTube and you can learn more math.
Hey guys, I wanted to go over this Reveal Math Module 1 formula sheet for Quadratics or Integrated Math 3. 1.1 we talked about the average rate of change. They're going to say, what is the average rate of change between these two x values? So when you see the brackets, it's not an order pair, it is a interval. Start here on the x-axis, then go there to the x-axis. You're basically finding the slope. There's three equations you can use. You can put in the b value, which is x2, into the function. Your a value, which is your x1, into the function. Subtract those, and then subtract b minus a. Or the same notation is just slope. M equals y2 minus y1 over x2 minus x1. So how do you get the y values? Well, you evaluate it separately. So put x1 into the function, you get an answer that's called y1. And then same thing, put in x2 into the function, you get a y2 value, and then use the average rate of change formula. In 1.2, we talked about the standard form of quadratics. F of x equals ax squared plus bx plus c. Notice there's no parentheses. The c value is going to tell you the y-intercept, and the a value, if it's positive, is going to open up, and negative, if it's a negative number, it's going to open down. Negative people frown. In standard form with no parentheses here, you can find the axis of symmetry. That is this green dot down here. And basically, from here, you just put in x equals negative b over 2a, substitute in your b and a values, and this gives you the x value. If you wanted to find the vertex, the lowest or highest point, you take the x value, put it back into your equation, you'll get a y value. In this case, my graph is opening up, so this is the vertex. The vertex is a point, a line of axis of symmetry. The line of symmetry is a line that goes through that point, and then the vertex is an order pair of the x and the y that you found. Okay, then you might be asked to find the domain and the range. You can't see here. So the domain refers to the x values. You're going to go from left to right. And my hint is, anytime you see two arrows, like quadratics, you will always have negative infinity to positive infinity for interval notation. For the range, you're going to go from the bottom to top, start where the graph starts. And then if you end, then you have arrows that would be a positive infinity going up. These points that cross the x-axis is all the 5 ways of solving quadratics that you're trying to find. That would be real solutions. They're also called x-intercepts, zeros, and roots. Okay, for 1.3, we talked about complex numbers. I squared equals -1, or I equals the square root of -1. 1.4, we talked about factoring trinomials when it has 3 terms, such as this. Make sure to set it equal to 0. Find your greatest common factor, take it out. Make sure it's in standard form, descending order, ax squared plus bx plus c. Identify the numbers in front, a, b, and c. You're going to use your x puzzle, your x method of factoring, or this is called area model. A times c goes in the top here, the b value goes here in the bottom, and you have to think of 2 numbers that multiply, or their product is the number on top, and you add those numbers together, or their sum is the b value. When you are finished, you're going to take those values and add an x to it, because that's basically splitting the middle term. Whatever is here in yellow, put it all there, c value there, and then you're taking the common factors out of it, going up and down. And then the things on the outside are your factors or binomials. If you want to check your answer, you take those and you multiply them, you get what's in the inside and combine like terms. This is an emphasis on factored form. Factor form basically means you factor them to get your greatest common factor, and your p and your q values, not including the minus sign, are your x-intercepts, your roots, or zeros, or solutions. And if your a value is positive, it opens up, negative, it opens down. Okay, in 1.5, we learned by solving the square root. Solving by the square root property works best when your a and your c value, you don't have a b value, or a b value is 0. Solve by square root property, factor, or take out the greatest common factor. You're going to take a perfect square trinomial, so factor on the left side. If it's not factorable, then isolate it, and you want the c value on the right side. Take the square root of both sides. Don't forget to write the plus or minus, split them up, and solve. If you are completing the square, you either want to move the c value to the right side by solving by the square root property, or just moving it over on the same side so you have some space. Complete the square by b over 2 squared. Then your c value that you find, you're going to add to both sides, or if it's the same line, you want those two highlighted marks to be added to 0, so the opposites, so positive 5 and a negative 5. And then you'll solve by the square root property. That also leads us to the vertex form. Y equals a times x minus h squared plus k. K is the vertex, which is the minimum or maximum. The h value is your axis of symmetry. So if that was a 6, then you could say the axis of symmetry is x equals 6. A value, same thing as before. Alright, let's talk about 1.6 over here. Quadratic formula, make sure it's set equal to 0, descending order. You want to identify the a, b's, and c's. Write down the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Substitutions, make sure you use parentheses there, and then you're going to simplify. 1.7, quadratic inequalities, less than or equals to. Those are going to be, if there's no line there, it's going to be a dashed, or if there's a line there, it's going to be solid, which means you include that solution. Dashed line means that you don't include it. Steps to solving quadratic inequalities: graph it, use your shading, or your dash or solid lines, and then you're going to pick a test point. Try to pick one that's not on the parabola. The best one to pick is always 0, 0, but if the graph goes through 0, 0, the origin, don't use it. And then you're going to shade accordingly. True means shade that area. If the other area that you graphed is false, then you don't shade it, shade the other region. Well, how do you solve quadratic inequalities? Solve by factoring or using quadratic formula, then graph it, your x-intercepts, and then your solutions, you want to use your test points like you did over here previously, but then you're going to use set builder notation. The inequalities, where there's false and true, you're going to put it into the set builder notation, and then these values are your interval notation. 1.8, we talked about solving quadratic systems. And so I just made a little chart. There's no solutions if there's no intersections. There's one solution if they cross once, and then there are infinite solutions if it looks like the same line. There's two parabolas on each other, or the lines, and then that one goes through 2 points. And then lastly, solve quadratic systems. Use the substitution method, which both are equal to y. So y1 is equal to, y2 is equal to, and then you can just set them equal to each other. You're going to solve the quadratic system by setting each of those equations equal to 0, and then go ahead and solve those quadratics. Try factoring. Those are the easiest ways. Get x value, and then how many solutions. Use your discriminant, b squared minus 4ac. If it's greater than 0, 2 solutions, equal to 0, 1 solution, and less than 0, 0 real solutions. And then you're going to use the x value to get a y value, which is an order pair. Hopefully that was helpful. See ya.
Yeah, 1 and 1 is 2, and 2 is 2 is 4. 3 and 3 is 6, so now let's try some more. 4 and 4 is 8, and 5 is 10. 6 and